Hello, algebra students. Today we're going to learn a lesson about factoring using an alternative method called factor by grouping. And our overall goal is that we're still rewriting our expression as a product of the factors. So we're still looking for those two terms that multiply together to give us that end product. And we know we've got it when we can create two factors using the grouping method where we can come up with the factors for x squared plus 3x plus 2. Alright, so before we start, I wanted to talk about factoring out the GCF because when we use the grouping, we look a lot for the greatest common factor, and you're going to see something a little bit strange, so I wanted to kind of start with this. So if we're looking here, both of these terms have in common ends, right? So we can factor out the GCF by taking the n out from both terms and writing what's left in the parentheses. We did this earlier in the unit. We're going to be doing it a lot in this video and for the next week or two. So in this term here, we're going to see, look, both of these have a 5n. So I can actually take out 5n, and I'm left with 6m plus 7w. Okay, so this is actually what it's going to look like today. Both of these terms here, I know that it's two terms, there's a binomial in the parentheses, but that binomial is the greatest common factor of both of those terms. So they both have in common x plus 2, so we can take out x plus 2, and what's left in the first term is just the 9, and what's left in the second term is the 8y. And so we're going to use that method when we're factoring today. I'm going to look at one more. So in both of these terms, we have a 7x plus 3 in common. So that's what's going to come out. And then what we have left is going to be 5x minus 6. And again, the 5x is coming from, just to show, the first term, and the minus 6 is coming from that second term. What's left once I take out that 7x plus 3 from both terms, that's what's left. Alright, so this is a different method, although it does the same thing. We're still going to get those two factors. It's just an alternative strategy. And we want to make sure that we're practicing this method as well as the area model. So we're going to get to the same answer, we're just going to do it about a different way. So this first couple steps are actually the same. We're going to write out the GCF, or factor out the GCF. So for this trinomial 2x squared plus 13x plus 6, there's no GCF, so we actually don't need to do that. So that part's done. We're still going to be looking, we're just not going to create the area model. So we're actually just going to do it. This is more algebraic and less using pictorial help. So we're going to just think, now that we've done this so many times, what adds to 13x but multiplies, and you're just going to kind of look at the ends because that's what we would have filled in on the model. So what multiplies to those two terms there? So that'd be 12x squared. And so you want to think about things that multiply to 12, 3 and 4, 12 and 1. So that's going to be the one that works, 12x and 1x. Okay, and that of course is always the most challenging part, right, of all of this. It's coming up with those two terms that we can break apart. All right, so this isn't really anything different besides the fact that we haven't drawn the area model. The different part comes next. So instead of filling it in, we're going to actually just rewrite this here using these two numbers here. I'm just going to highlight them. So we're going to rewrite the 13x. We're going to rewrite it so that it's 12x plus 1x. So I'm going to keep the 2x squared. I'm just going to change out the 13x. So plus 12x plus 1x plus 6. So we're just going to write it all out. And, you know, if we went back to when we were distributing, you would actually see this middle step here where we distribute each term. So from there, we're going to keep moving through this list. So we rewrite it using the terms. The next part's where it gets a little bit different, but we'll do a couple examples together. So what you're going to do is you're going to kind of break this up into two separate problems. And in the first part, we're going to factor out the GCF of the first two terms. So I'm going to look just at 2x squared and 12x. And if you think about this in the area model, this was actually when we pulled up the GCF. So it's the same kind of thing. So factoring out, so both of those terms have a 2 in common, right? That's a GCF, and then also an x. And then I'm going to rewrite the second part of it in parentheses. So if I take out 2x, then that means that I have just 1x left. 12x divided by 2x is just 6. So that's what it looks like. Then what you're going to do, that kind of checks off step 4, factoring the GCF in the first two terms. Then we're going to factor out the GCF in the second terms. I'm actually going to remove this a little bit out of the way. There's not much space. Okay, so if I look at 1x and 6, the only thing they have in common is a 1, a positive 1. So I'm just going to put plus 1. We always want to write the 1, even though it's kind of weird to write that as a GCF, but we want to make sure we do that on the outside. And then what I have left is just x plus 6. So just to kind of recap what we've done thus far. So we found the two terms that multiplied to 12x squared, added to 13x. Now we've pulled out the GCF of the first two terms, then we pulled out the GCF of the second two terms. So now you'll see that both of these, and this is the part that's wild, have x plus 6 in common, and these should always match when you're factoring. Both of these should have x plus 6, so we can actually take out the GCF of those, which is x plus 6. And then what I have left is just what's ever on the outside. So in this case, it's a 2x and a plus 1. And that's it. That would be your answer. And so again, that last step, because I have the x plus 6 in common, I can pull that out, and whatever's left on the outside of the parentheses, that's what goes in the end. So once I take the x plus 6 out, I got 2x left, and then I got a plus 1. All right, it's a little bit faster, honestly. That's the biggest advantage to this way. You don't have to draw the picture, but it's definitely more abstract. So we want you to feel comfortable with area model, and this is just an alternative method. Okay, we're gonna do like maybe 2 more in this video. So again, I'm gonna start out the same way. I'm gonna look for a GCF, but the middle term is 1, so there is none. So I'm looking for what adds to 1x, since that's our middle term, and multiplies to, let's see, that would be 72, right? Let's put the right sign. Hang on a second. Should be a negative 72 x squared. So we're looking for two terms that add to 1x but multiply to negative 72x. So you want to think about things that multiply to negative 72. That would be 8 and 9 is probably the most. Negative 9, negative 8, negative 8, negative or positive 9. So to add to a positive 1, that's going to be the one that works. So let's see, that's going to be negative 8x and a positive 9x. So then we're going to rewrite it. We're going to start with 6x squared, same thing. But instead of writing 1x, I'm going to replace the 1x with these two terms here. So, and it doesn't matter which order you write them in. So I'm just going to rewrite them. And these two expressions are similar to one another. They're the exact same thing once you simplify it. It goes back to, if I combine the negative 8x and the 9x, it goes back up to the top. So then from there, I'm going to again take the first two terms, and I'm going to factor out the GCF here. So 6x squared and negative 8x, both of them can be divided by 2 and x. And so what's left, we have 3x and minus 4. And then I'm going to do the same thing for this here. And so 9x and negative 12, so both of those are 3. And I'm going to put, since it's a positive 3, I'm going to put plus 3. And then that's going to be 3x minus 4. And a good check is that once you factor out the GCF, both of them should match. So the last step is going to be this term and this term, since they both have 3x minus 4, that can be pulled out. Factored out really of each term. And then what do I have left? Well, 2x in the first term and a plus 3 in the second. And that's it. Okay, maybe we should do this one just because it's practicing the same skill of trying to get it to what that middle term is. So actually, I probably want to do, I'm changing my mind, sorry. One where it's a positive and a negative. That's kind of a pain. That's okay, we can do this one. All right, let's actually look at this one here. So again, we're going to start the same way. Oops. We're looking for something that's going to add to negative 22x and multiply to 40x squared. So we know if it multiplies to a positive, that must mean it's going to be two negatives. So we're looking for double negatives. So negative 20 and negative 2. If I multiply that together, I get 40, but when I add it, I get negative 22. So those are our two terms for this one. And again, that's always kind of the tricky part. So then we're going to rewrite the negative 22x using these terms here. So minus 20x, minus 2x, and plus 5. And so from there, I'm going to look and say, okay, my first two terms are these. What can I divide both of those terms by? They are divisible by 2, but we want to get the greatest common factor, so they can also be divided by 4. And they both have an x in common, so that's 2x left minus 5. And then looking at both of these terms here, I'll like move this out of the way again. Oh, oops, I did like too much. So if I look at those two terms, you're going to say the GCF is 1. So let's just say that. And then what do you have left? You have negative 2x plus 5. But if you look at that, these two terms here do not match. And we want them to match. And you'll notice that it's a sign difference on that second one. It should be a positive 2x plus 5. So in this case, we kind of have to go back and rewrite it so that it's not a positive 1, but we're actually going to take out a negative 1. We have to get them to match in order for it to work. And so that's going to be, then it would match, because that would just be 2x minus 5. And so the last part, you take both of these terms, come out, so they both are in common. Oops, I like highlighted the wrong thing. Both of these terms are in common, the 2x minus 5. So we're going to take that out. And then what do we have left? 4x in the first term and a minus 1 in the second. Alrighty, hopefully do some practice on this one. I know that it's kind of hard once you learn something to keep trying a different method, but make sure you're practicing this one as well, and then make it a good decision of what option you like using better. Have a great day. We'll talk to you soon.